In this video we shall talk about fundamental database requirements any database should comply with. Such requirements deal with subject matter adequacy, with technical usability, performance and data safety. And now we shall review all those requirements in details. Let's start with subject matter adequacy. Sometimes violation of this requirement may look rather simple. Let's review such a table about a person. We see that here is surname, name, middle name. That's good, that's okay. But then we see CPU frequency. What's this? How is this a characteristic of a person? For now, a person does not have a CPU installed. So that's a mistake, that's a violation. But this violation is easy to see and to fix. Of course, this field should be moved to some other table. But sometimes subject matter adequacy violation may not be so simple to see, to detect, to fix, and yet it will be extremely dangerous. Let's review such a database schema. Here we see student, subject, tutor. We see that a student learns a lot of subjects, and any subject may be learned by a lot of students, so many-to-many relationship is okay here. We understand that a tutor may deliver a lot of lectures on different subjects, and each subject may be delivered by a lot of tutors, so many-to-many relationship is okay here. And of course we understand that each tutor may teach a lot of students and each student may be taught by a lot of tutors. So many-to-many relationship is okay here. So what's the problem? Please pause this video and try to find the problem yourself. So here is the answer. The problem is the next. Imagine we have to find out for each student and each subject and each tutor this correspondence. So what student learned what subject delivered by what tutor. This information is not here. And we cannot recover this information by any way, by any attempt, by anything we do. This information is lost forever. So such subject matter adequacy violation is hard to detect, but nevertheless it may be extremely dangerous. So in case you want to know how to fix this violation, here is the answer. We may switch our database schema to such schema as star schema. We can see the central table and some satellite tables. So here we see information about some lessons, about some classes, and we see that a student was at that class was of such type, of such subject, and delivered by that tutor. So everything is here, and that task defining what student learned what subject delivered by what tutor is easily done by such a schema. The next requirement deals with technical usability. Technical. Here we do not speak about usability for end users, because those end users may even do not know anything about databases or something like that. So what do we see here on this picture? We have to find out some specifics about a date. Maybe you've seen such information on a door of some shop saying that, for instance, every second Friday, 5th day, is a day for some technical maintenance or something like that. So we have a date and we have to find out which week of the month is it and the number of the day. If we only store the date but not that information, we have to perform such SQL query. For instance, you may pause the video, you may look through this query and find out, is it easy for you to understand that query, to write that query from the scratch, and you may speculate on, is it difficult or easy to make some mistakes here? From my point of view, this query is difficult and the probability of making a mistake is high. But if we store that data from the beginning, we create some decision to find out that information and store, and then we may use such a simple query, it's easy. The probability of making a mistake is extremely low, so this approach is good for technical usability. We have to think in advance, to think about the future and create some technical decision that allows us to make more simple technical decisions in the future. And here is another example of technical usability violation. Imagine we have some database table about persons, we see surnames here, and we see initials. And please note that here we have points, here we do not, here we have single symbol, here we have 4 symbols, 2 symbols. And then, at some moment, we have to order the table by surname values. So we have to somehow eliminate those initials. This technical decision is not so easy as it seems. It will significantly decrease performance, there is high probability of making a mistake, and so on. But if we, from the beginning, rearrange the schema, if we store surname and initials separately, here we have no problems at all. We just use order by operator and we easily sort this table by this field without any additional operations. The next fundamental requirement tells us that your database should perform good, perform fast. This is a rather difficult topic because it requires a lot of technical knowledge, a lot of technical skills, but from the beginning, when we just create database model, we may think about data types, if we select good data type or if we can select something better. We may think about field size, so it will not be too large or too small. We may think about indexes, if we've created all needed indexes and we do not create any unnecessary indexes. We may think about materialized views. Do we need them? Have we created them if we need? Have we not created something that will only break the performance? We may think about caching, tables, fields. Have we created them? How we update them? How that all influences the performance. Of course, we shall need some performance testing to prove our decisions or to correct our mistakes, but we shall absolutely think about all those ideas from the beginning. Speaking about data safety, we should emphasize that we do not speak about access permissions and something like that here. We only speak about the data safety against our incorrect operations. Imagine such an example. Here we have a table to store a tree structure. If you are not familiar with trees in information technologies, let's make a quick review. So a tree may look something like that. Yes, it's going upside down, unlike ordinary trees in real life. So you may imagine such a structure. So such a structure may be stored using that table. But what if we have to cut the tree here and, for instance, move all that branch here? What if we want to remove this point and make that one the root of the tree? What if we going to perform some other operation on this tree? Is it safe? Do we have necessary storage routines or something like that to perform that operations? Because if we are going to just use some SQL code and perform some, for instance, update on that table, we risk a lot to break something in that tree structure. We risk to finish with just pieces of that tree. And we cannot allow such a situation to happen. So we have to think about data safety. We have to create all those necessary mechanisms to perform that operations safely. All these fundamental database requirements are extremely important. So please memorize them, because we shall refer to them a lot in our course lately.